It's an interesting question. What is the maximum value of sine x? What is the maximum value of sine x? 1. Okay? Think about what the graph of sine of x looks like. Okay, we start at 0, going up, and how high does it go if you just have sine of x? 1. How low does it go? Negative 1. How about cosine? Same thing, negative 1 to 1, right? And if you notice, look in a unit circle. Remember, the unit circle went from 0, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, and then went negative for your different things. But all your values for sine and cosine are between negative 1 and 1, including the end. Is that the same for tangents? So, I want you to find an angle, using your calculator, that will give you a high tangent. See if you can find one that's over 100. So find some angles that when you take the tangent of it, you get a number bigger than 100. Put tangent and choose an angle. Find an angle where if you take the tangent of it, it is more than 100. Anybody getting somewhere? Okay, so here. Okay, can you make it bigger? Okay. So, you got tangent of 89 equals what? 57.2. Can you get bigger than 57.2? Or 57.3? Okay, see what happens.
Oh.
Okay, so we got one. Tangent of 89.9. What do you get? If you're in degree mode. Now, if you can do degree or radian mode, but probably easy on degree mode. Okay, what do you got? Okay, so he's now at 572,000, or, yeah. Okay, 957, 572, 957.
89.1.
Can you get bigger than 1 million? Okay, what do you think this means we have? Is this increasing without bound? So this is going to infinity. Okay, everybody seen how you can get a big number? You're in degree mode, getting it. Okay, so really big numbers there. So, what number are we approaching?
Oh.
Okay, and what x value, or what are we taking tangent of? 90. What is the tangent of 90 degrees? Undefined. Does this seem similar to something else we've done this year? Like 1 over x. As you put a number closer and closer to 0. Yeah, we can asymptote. So, one of the key things when we look at tangents is you're going to have asymptotes. As I said, asymptote plural. Is tangent periodic? Does it repeat the same pattern over and over again? Yes, because you're going around in a circle, it starts repeating. However, the interesting thing with tangent, how often does tangent repeat? Okay, is it every 2 pi? So, what is tangent of 0, for example? Come on, man. 0. Tangent of pi 4. 1. We get 0, 1, undefined. What over here? Negative 1. Here? 0. Here? 1. Here? Here? That's going to repeat more than just every circle. So you have negative 1, 0, 1, undefined, negative 1, 0, 1, undefined. What? Yes, pi over x. So how often does it repeat? Every pi. So the period for tangent is, instead of being 2 pi, like sine and cosine, it is every pi. That's because when we got down here, a negative divided by negative is the same as a positive divided by a positive up here. So everybody with me on that? Now, what is the domain of sine? Oh, right up here. And we said the range is from negative 1 to 1. The question is, what is the domain of tangent? Is there places where it's undefined? Yes, so look at here, 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 back here, here. So how are we going to describe that? Let me get rid of that. So y equals tangent of bx. No, so the same structure we did for sine x. So first, the period is that it repeats every pi. What do you think b is going to do to it? Change the period, right? Okay. Do you remember the formula for the period of a sine or cosine graph? 2 pi over absolute value of b. What do you think it will be for a tangent graph? Yeah, pi over absolute value of b. Does everybody follow where that came from? Because remember, sine cosine repeats every 2 pi, tangent repeats every pi. What's the domain? Okay? All real except x cannot equal what number? If I have 3 pi over 2, what about 5 pi over 2? 7 pi over 2. Yeah, well, it can't be 5. It can't be 5 over 2, right? You see why that doesn't work? Okay. Remember, tangent is y over x, right? What's x at pi now? 0. We have 1 divided by 0, which means you can't do it. So again, that's fine. So remember, the things we look for the domain are divided by 0 and what's the other one? What are the two things to look for the domain? Square root or even root, causing what kind of numbers? Imaginary numbers, good. So, when you're doing a tangent, you don't have to deal with imaginary numbers yet. That will come later this year. But we do have to deal with divided by 0. Yeah. So, a tangent, we can't do tangent pi halves. What else? 3 pi halves, right? Because then you have a negative 1 over 0. All the odd pi halves. And how often do we say pi or tangent repeats? Every pi. So we can write an equation that says pi n. N is an integer. So this means that we can't have x equal any pi halves plus any multiple of pi. Because what would happen if we did plus 3 pi? Pi halves plus 3 pi would be 7 pi halves would be a problem. Did you understand this part? Now, what's the range? Remember, we are showing you guys getting like the tangent of 89.99999, and you're getting going up to billions, right? And it doesn't make sense that you could do go down to negative. What number do you think you'd have to put in for there? So try tangent of negative 89.9. What do you get? Okay, so the negative thing. So yeah, we're going to go down to negative infinity. So tangent. So now let's start thinking about what we know about it. Okay, we know it's got an asymptote on one end, at pi half, and 3 pi half, or negative pi half, or 90 degrees and negative 90 degrees. We know it's got an asymptote going down on one side. Alright, down on one side, so from your perspective, it's from here, up over here. It means there has to be some sort of connection between them. Right? So are you sort of visualizing in your mind what the graph looks like? So let's pull this out. And let's see. So where is it undefined at? Okay. So at pi half, so I'm going to do a dashed line for an asymptote. At 3 pi half, at negative pi half, okay? You see where those came from. I'm not just arbitrarily putting lines up there. Okay, so what is the tangent of 0? Okay, remember, 0 divided by 1 is 0. What would be the halfway to pi half? I'm going to put that in here. What is the tangent of pi 4? 1. That's one of the reasons it's nice to have this pi 4th, is because we know at pi whole fourth it's 1. What about negative pi 4th? Negative 1. Okay, what's going to happen over here? What will be the tangent of pi? 0. And then 1 and negative 1. Well, it's not tangent's not that hard. Yeah? But everybody visualize the picture of it. And this would repeat over and over again. So one of the goals if you're graphing tangent is first identify where your asymptotes are going to be. Now we run into the complication.
How do you know how to set up your graph?
Okay. So let's do one a bit more complicated so we can go through that. Y equals, say, the tangent of, say, 2x minus pi. Something like that. Okay? What is the first thing you want to do? What is the period of this? Okay, remember it's pi over b, right? So pi half. So it's going to repeat every pi half. Now, that's for sine and cosine, it's 2 pi over b. For tangent, it's just pi over b. So, everybody with me, it's going to be pi over 2? Okay, so no, when it was this one, we went to pi half. We went by pi fourth, each one was pi fourth. So you cut the period in half, I would go by pi 8. It's similar. However, note, we already do have a shift left or right. So this would be 3 pi over 8.
Can you just leave the same graph?
With this one?
Yeah, can you do that in a move?
Okay. So what direction are we moving and how far? Okay. Now we could leave the same thing, but notice, instead of being pi fourth, it's going to be, each one of these things are going to be cut in half. Because the period, because from here to here, instead of being pi, yeah, it's going to be skinnier. So I prefer to redraw this. So first, where are our asymptotes going to be? Now, the problem is because of the pi here. Here's one way of finding it. This is just a quick, sturdy way to do it. 2x minus pi equals pi half. Where is it true? Remember, pi half is one of our asymptotes, right? So if I add pi, I get 2x equals 3 pi half, divide by 2 times 1 half, 3 pi over 4. So pi half plus pi is 3 pi half. Divide by 2 is same as multiply by 1 half. So 3 pi fourths is going to be one of my asymptotes. Now, what is my period? Pi half. So if I subtract, take 3 pi fourths minus pi half, where am I at? Pi fourths. So this is an asymptote here, pi fourths. And then 1 pi fourths, 1, 2, the 2 pi fourths, 3 pi fourths would be there. What I just said is took this part right here and said this equals pi half.
Is it always pi half?
You know pi half is an asymptote. Negative pi half is an asymptote, right? Guaranteed. Therefore, whatever makes this pi half is guaranteed to be, yeah. Whatever makes this part pi half is guaranteed to be an asymptote. And I can shift it around.
But then, what did you do when you
Okay, I was just moving it from over here to here, just one closest to 0. By subtracting one here. Because remember, it repeats every period, so the next one would be there. So it actually, so by setting up the graph this way, it actually can be the exact same graph, just different labels. So just if I do 0, 2 times 0 is minus pi, tangent of negative pi, 0. If I plug in pi 8 this time. 2 times pi 8 is pi 4. Pi 4 minus pi. Negative 3 pi 4. Tangent of negative 3 pi 4. Positive 1. Remember, negative 3 pi 4 would be down here. So positive 1, we get the point there, we get the point there, and we can draw the line.
Will it always be like that?
Well, like here and here, you mean? Well, assuming you have a 1 here and don't have any other number, it will always be over 1, up 1 from wherever you start. If you set up the scale that's right. You know, no.
How would you set up the scale?
Yeah, like what I did, I set it up by going each one of these, each line is 1/4 of the period.
And then it'll be almost.
Yeah.
Correct.
Well, no, even if I shift it to the right, if it was the right pi half, it would still be over 1, the period is still pi 4. Or if I do the line to pi 4, the period is still the same. Probably. But anyway, how does it change it? For example, if this was a 4 here, I could just say this is now 4, and I'm done. Don't make it harder than you need to. What? I need to use the calculator, but you need to be able to do it by hand too. However, this is just tangent. We also have cotangent, secant, cosecant. This is just tangent. So, what do you expect the period of secant and cosecant to be? Okay. What do you expect it first? What do you expect the period to be? Okay, what's the period of sine and cosine? 2 pi?
Would it be as the value of
That's us, 2 pi over p. Because it repeats just the way sine and cosine repeats. And in case you're in doubt, cotangents have the same sort of thing. Cotangent is very similar to tangent. Because the easy ones. That one would be like secant and cosecant. This gets a bit trickier than tangent. So let's just do first y equals cosecant of x. I like cosecant better. What is the period? 2 pi over b, in this case b is 1, so 2 pi over 1. So let's see, call this one pi, 2 pi, 3 pi, and 4 pi. What is, let's make this one b1 and this one. What is the cosecant of 0? So what is sine of 0 first? Sine of 0 is 0. Cosecant of 0 would be undefined. How about the sine of pi? Sine of pi is 0. Cosecant of pi? Undefined. 2 pi. Okay. Now, halfway between here, what would the middle be? Pi half. Half of pi. What is the sine of pi half? What is 1 divided by 1? 1. Okay, 3 pi half. Negative 1. 5 pi half. So now, what are we going to do between them? So let's say if we do this one, let's say this is halfway there, pi 4. Okay? Sine would be root 2 over 2, right? What would 1 divided by root 2 over 2 be? Or 2 divided by root 2? With your calculator, what do you get? 2 divided by root 2. 1.4, which is root 2. So at this, we are at 1.4. How about this one x? We did 3 pi 4. Same thing. So not quadratic, but it's similar to it. Yeah, negative. It's going to be, notice it would be a negative 1.4 here. And over here, same thing. Okay. So there's cosecant. What do you think secant would look like? Okay, similar to it, however, slightly different. It will be shifted over just slightly. Because what is the cosine of 0? 1, right? So if we're doing that, it would be 1, 1. How about the cosine of pi? Negative 1. Cosine 2 pi? 1. Okay? No, what about if we did pi half? How about undefined? And over here, so we end up with secant doing this. Okay? Have you tried graphing sine and cosine? What does it look like? So, sine x, cosine x.
You have to.
You'll have to do some graphing, yes.
No, like,
Yeah, but we just shifted over from each other. My cosine just shift of each other, secant and cosecant just shift of each other.
do we have to range?
I think it's a good idea, but I may not look for it.
So, it's nothing.
Yeah.